Is Beth Guertal is the Rowe Endowed Professor in Crop, Soil, and Environmental Sciences at Auburn. Dr. Guertal received her BS and MS degrees from Ohio State University and her PhD from Oklahoma State. She works in worm seeds and turf grass. She's past president of the Crop Sciences Society of America and is also a writer. So as I go through this, I'm going to depend on her to correct the inaccuracies of anything I say about turf, growing grass. There are some big trends in North American racing that we've alluded to, and I want to just kind of put these out here since my focus is on racing. If we look at overall in racing, the financial model, the pari-mutuel pool is flat. The Racino model remains where casinos support purses. There's some distortions in the market because changes in the business model and the pandemic. The decline in full crop, number of starts is down, and the starts per horse is down from historic levels. There's also a huge risk in public perception, and this isn't just true in North America. Worldwide, we see horse welfare and rider safety, as well as the perception of racing is an existential risk. So as I mentioned, total starts are down, but there's some differences between the surface. Most of the decline in racing is on dirt. The trend might be reversing, but it's not clear. The total starts on synthetic surfaces is down. Again, the trend might be reversing, but that's dependent on new synthetic surfaces being installed. But turf shows a clearly different story. Turf racings are flat or slightly increasing, and as a total percentage of racing, it's increasing. There was a question in one of the previous talks about whether this was safety related, and I want to address that briefly. Turf sits between synthetic and dirt. Dirt is about 1.91 catastrophic injuries per 1,000 starts. Turf is at 1.46 per 1,000 starts, and synthetic is 1.818 per 1,000 starts. So it's not really driven by safety, but there's certainly a demand on, and field size and fan enthusiasm is very clearly in its favor. If we look at 2009 versus 2020, which are the same dates the equine injury database has data, if we look at 2009, turf really was pretty much a niche. At that point, synthetic, which is the gray piece of pie there, was actually larger than turf. If we look at 2020, it's 20% of the total market, which is clearly a growth area. So it's obvious that this is going to put a lot of pressure on surface maintenance, as Brian Jabelman mentioned. I want to reiterate then, thinking about this in turf, racing in particular, that there's different functions during the gait phase. If we look at the hoof contacting, it's going to slide, as Dr. Hobbs mentioned, and you actually want that small amount of failure of the surface as it moves forward to allow it to slide, which will actually reduce the overall loading on it. However, you've got a very different function during propulsion. If you look at the propulsive phase, especially in the hind limbs, your goal is really to be able to provide a surface that will not fail during that propulsive phase. You see that most clearly if it produces a divot, which would be the result of a failure of the surface. As Dr. Hobbs mentioned, that initial impact you need that lower vertical modulus or less stiffness, and then that reduces the strain rate and the peak loads. And as that slides forward, you actually have a slight shear failure as the hoof slides forward in the surface. During breakover, or the propulsion, you want the horse to support. And during the turn, so at that point, you want the hoof to slide initially, but you want the hoof to stay in its position during propulsion and turning. This seems contradictory, but it's actually quite possible because of the characteristics of the material, because once you put the weight of the horse on the surface, the strength of the surface is increased dramatically. So what's actually happening during those shear strains when it fails is there's deceleration is during the lightly loaded portion, and the weight produces that normal stress in the soil. Then it fails along the principal axis or the shear of the soil. So there's actually a failure within the soil underneath the foot. So what's so great about the structure of turf? Well, if you think about the motion of that hoof, turf is a uniaxial granular composite. There's the sand, but vertically going through the sand are the roots. Those are a fiber that supports the hoof as it's coming down. So the root system supports the hoof, but because the toe is penetrating down between the root system, it allows the toe to penetrate between the roots during breakover. Then during propulsion, that toe is down between the root system, and the roots will strengthen the material, allowing it to, keeping it from failing and allowing the horse to move forward without divoting it out. So a strong root system will actually allow that hoof to penetrate down in. It's also got this feature that doesn't exist in other materials, in that it's self-healing. If you can allow it a chance to grow back the roots that are cut as the toe penetrates through will then grow back. It's interesting to think about this in the context of our second talk, though. A lot of those cultivation techniques encourage the vertical growth of the roots and also break up the top surface of the racing surface so that the toe can penetrate down in. Peter talked about some of the existing tools, the Clegg hammer. It doesn't correlate to race times and does not match the biomechanics. The going stick's promising, but the link to biomechanics is tenuous at best. And it also assumes a depth of cushion, turf homogeneity, and also can be user dependent. The penetrometer is perhaps the most well established, that and the going stick. But again, there's little or no published data on performance or risk. Moisture content, there is a fairly reasonable literature on that. But none of these tools are correlated to injury. Biomechanics has to drive the measurements because we do not at this point know what else can be used. So if we look at track materials, these are both synthetic and natural, they're all nonlinear. The more that you load the material, the higher the modulus or stiffness. They're all strain rate dependent. So synthetic and dirt, they're dynamically controlled. So if you load them quickly, they are much harder than if you load them slowly. And the other aspect of this is there is a hoof involved in this that has very specific lengths. That's one of the things that you see in the penetrometer or the going stick. What both of those are attempting to do is look at the characteristic lengths, the pieces of the shoe that matter in order to get a hold of the surface, and they specifically address those characteristic lengths which are associated with the shoe itself. The Orno Biomechanical Hoof Tester is an open source design, and the development is shared. And Lars, who's speaking later on, and Dr. Hobbs both were intimately involved in the development of that. There's also laboratory testing, but again, this becomes very difficult for turf because removing an intact sample from turf, a lot of the laboratory testing that we depend on for synthetic and dirt surfaces are not available. So again, our number of tools that we have to correlate to injuries are much more limited with turf. So our challenge with turf is that we need a large data set. The Equine Injury Database is an incredible tool that's available for North American racing. There's 12 years of data on more than 95% of all flat starts. Data is taken in a consistent manner for catastrophic injuries, meaning that the horse is euthanized within 72 hours of the race. Equibase data from the Jockey Club information systems is available for all other race-related data. That would include rider, horse characteristics, race characteristics. What we know from the EID, as I mentioned before, is that the lowest rate of catastrophic injuries is on synthetic, but dirt is at 1.91 per thousand starts versus turf at 1.46. The interesting effect of that, though, is that we also know that some of the safest surface are dirt, and that both dirt and turf vary dramatically between years. So whatever surface data we develop needs to be consistent. It needs to be based on the biomechanics of the horse and or the mechanics of the material, and it needs to be combined in a relational database for analysis, because what we need to do is begin to take the surface data and press it up against the equine injury database. And that's the idea of the maintenance quality system. The maintenance quality system is an ISO-type process. The goal isn't to define the maintenance process or tell people what to do. It's asking them what's going to be done and how it was inspected. This is common in medical and aircraft and other safety-related disciplines. If you look at a racetrack, what's happening on a racetrack is every day a safety critical system is being deployed for the horse and the rider. The MQS process starts out with developing the documentation. Peter called it the flight certification. Then the paperwork, the pre-race, the pre-flight inspection, and the data logging is all electronic in a relational database. And then the goal has to be able to review the good outcomes and the questionable outcomes, and with the equine medical director, the racetrack superintendents, and also communicating with broader constituencies, owners, trainers. One of the things, like aircraft safety or medical safety, is every year we need to improve. The safety, performance, and cost need to be improved over time in order to protect our participants. This is an overall culture of data for surfaces: horses, riders, jurisdiction, and training information. And then this goes into the relational database that currently has surface data for 14 tracks. So one of the things that's happening at this point is the Horse Racing Integrity and Safety Act, which may expand some of these activities and provide more consistency between racing jurisdictions. So let's review a moment. Again, we have different functions during the phases of loading. We have low vertical modulus and shear failure and high peak load. Then during breakover and propulsion, we have to support the hoof. So what have we seen out of this? With the OBST that you can see operating down in the bottom corners, bottom left, you can see that hit in the slide, that motion, and it simultaneously measures the 4 parameters that Dr. Hobbs mentioned. So grip, to give some sense for people who know horse racing, the synthetic versus dirt, we see significant differences in slide. What's most notable, though, is with the synthetic surfaces, off of these 6,000 tests done on 80 racing and training surfaces, is the synthetic shows much lower variability. 10 years gives us a lot of statistical outliers as well. But if we look at the biggest difference, it is the difference in the variation between the two of them. There's no equivalent for turf. The current tools are inadequate. Cushioning, we have 6,000 tests and 80 racing and training surfaces. And even in cushioning, we see the dirt overlap synthetic surfaces, again, with dirt being much more variable. And there's no equivalent for turf tools. But what we do know out of all of this data is that's critical to track data is the maintenance and the weather. The weather data is taken from a standard station that's a standard track location. Water application is critical, and improved irrigation systems. This is one of the things we've seen in the industry, and it's been certainly evident in New York, Woodbine, fairgrounds. We've seen almost throughout the industry and efforts to improve the quality of the irrigation systems.
This is Karen, and this is her land. She's been here a long time, along with Mojo. The first fence post went up here. Now there's 5,000 of them. After the storm, she started the cleanup here. And when she needs some peace and quiet, she always finds it right here. This is more than just land, it's home. Karen runs with us on a John Deere 3E Series tractor, because who says a day's work has to take all day? Nothing runs like a Deere. Search John Deere 3E Series for more.
Being a teenager and in high school and middle school is not easy for girls these days. And they get to come here, spend time working around the farm, spend time with the animals, and not feel that pressure until we go to horse shows. The first time I saw this land, I was about 12 years old. I came here with an old mentor. I fell in love with it as a little girl, and I said I was gonna own it one day. My mother, when I was 4 years old, put me on a little pony walking around the zoo. That was it for me. Love at first sight. Like any kid, when I was younger, I wanted to compete more in the Olympics and go Grand Prix and do things like that. But I put that all on the side and realized I had a different agenda in life. I've taught about 800 kids in this area. A typical day starts early in the morning with feeding the horses. Then usually we clean stalls. This is a daily chore, sometimes twice a day. I'm always on the tractor, mowing, spreading things around, you name it. This is a John Deere 3025P. I love my tractor. I couldn't live without it. I like to just relax and be left alone. I call it my husband. He's very reliable, and it doesn't argue. It's so easy to use. My 68-year-old mother has never driven anything like this before, and she was scared to death of it. And once she did, she loves it. She drives it all the time for me and helps me out around the farm. Being here in Florida, we deal with a lot of hurricanes, so it can be very stressful when we're in the path of one. That John Deere helps me so much. We go around picking up debris, moving, pushing things with the bucket. I always have an average of 50 students, so whenever there's a disaster that comes around, they're always here and they're ready to work. I call all my girls my kids. They're like part of my family, and they get scholarships for riding, and so we try to keep our sport here a little bit serious but fun. We go to the horse shows. It's great for them. Good, very nice. Teaches them a lot of sportsmanship, how to be more in charge and have more self-confidence. A little stronger on that. There. The parents tell me all the time, you are such a huge influence in our child's life. I love to share my experience with these girls and be able to steer them in a better path. Everybody always asks me, how do you keep doing this? I say, just the sheer passion of it. What am I gonna do? Get a condo on the beach somewhere? I'm happier here. I'm Karen Neese, and this is my land.